Welcome to Brain Vision.
Okay, so we're doing chapter 37, problem 82 here. So it says, show the magnitude of electrostatic potential energy of an electron in any Bohr orbit of a hydrogen atom is twice the magnitude of its kinetic energy in that orbit. Okay, so the electrostatic potential, we can look back at equations 23.5 to get that. And we can look at the kinetic energy related to the total energy by equations 37.14a. And the Bohr radius is given by equation 37.11. So these are some of the equations we can look back at. So first of all, we know that the potential energy here is negative E times V. And we can write this as negative 1 over 4 pi epsilon naught times, for hydrogen-like atom, Z E squared over Rn. Okay, so now we can relate this as at the Bohr radius here, plugging in the Bohr radius in here, and this becomes negative 1 over 4 pi epsilon naught. And we have Z E squared pi m Z E squared over n squared h squared epsilon naught. So let's cancel some or simplify things here, and we get a potential energy of negative z squared e squared m over 4 n squared h squared epsilon naught squared. So this is our potential energy now. So we want to show that the potential energy is twice the magnitude of the kinetic energy. So that's saying that the magnitude of U over the magnitude of K equals 2. So first, now we need to figure out what K is. Well, K can be written as the total energy minus the potential here. So the total energy is given as negative z squared e to the fourth m over 8 epsilon naught squared h squared n squared. And now we can subtract off our U. E squared m over 4 n squared h squared epsilon naught squared. Okay, I just now realized there was a typo, right? So up here, there's e squared once here and e squared once again here. So this should be e to the fourth, sorry. Which means these are going to add. Press great because they have common denominators here, just 1 over 4 and 1 over 8. So if we multiply this, if we multiply the top and bottom over here by 2, then we're going to have this. And we can plug this out to be z e to the fourth m z squared e to the fourth m over 8 n squared h squared epsilon naught squared. Awesome. So now if we plug in magnitude of U over magnitude of K, let's see what this is. Z squared e squared m over 8 n squared h squared epsilon naught squared. Sorry. We have U up top here, right? Magnitude of U, so this is negative, but it's magnitude or absolute value of that, so that's positive. And the bottom was 4 n squared h squared epsilon naught squared. Okay, so now 1 over K gives us on top 8 n squared h squared epsilon naught squared, and on bottom z squared e to the fourth m. Okay, so we should see these all cancel out perfectly, these cancel out perfectly, and then we just have 8 over 4 equals 2, which is exactly what we wanted to show. Awesome.